Hello guys, so we have here a Makita Circular Saw and we're gonna see if we can fix this. As you can see, it's been rusted and dirty. Try to spin the blades but it's hard, so maybe the bearing or gears are stuck. Okay, so we're gonna open this up and see what we can do for this power tool. Okay, the first thing we gotta do is we check the carbon brush if it's still in good condition. So as you can see here, it is stuck up and the carbon brush is a little bit dirty. So we need to clean that and the carbon brush holder. Okay, don't forget to check the other side too if it's in good condition. And as you can see, it's pretty much clogged, the carbon brush holder. When I try to pull it, the copper wire snapped. So I have no choice here but to leave it at its ease and just open up the power tool. So we're gonna speed things up here so you won't get bored. And a little reminder is don't plug your power tool if it's stuck up or the blades or gears are stuck up. It might cause much more damage. Okay, so the armature seems to be in good condition, but it has a lot of dirt and the gears are spinning correctly with no trouble. The bearing also spins good. So the cause of the stuck up really is the carbon brush. We're gonna deal with that later. We're gonna clean that holder up. Okay, so this is our field coil and it's in pretty bad shape. It looks burnt. So I think this is the real problem. But mostly for a burnt field coil, the armature is also damaged. So we gotta check the armature if it still works. Okay, so we put our armature in the growler and see if the blades of the cutter will be magnetized, and there's none. So the armature is in good shape. So we're lucky that the armature is good and the only damaged part is the failed coil. As you can see here, I've shorted the commutator and this is how a damaged armature will look and tested in a growler. We'll remove the field coil and we're gonna speed things up here so you won't get bored. And by the way, if you find this video very useful and it help you in some ways, then please feel free to like and subscribe and also comment down your thoughts about this repair. Thank you. Just look at that damage, and there's even an egg here, so this has been in standby for a really long time now. Okay, so we're gonna take this field coil, clean it up real fast, remove the wires, count the number of turns, and then repair it, rewind it. Here I have started counting the number of turns in this coil, and I have found out that it is 115, and the gauge for this copper wire is in American Standard 22, number 22. Here it is. I've bought a half kilo of wire, and we're gonna use this to rewind the field coil. Here I'm using a sandpaper for the insulator, but it is not recommended. I recommend you guys to use a real insulator like mylar paper, but for this repair this would suffice. Okay, so it is not recommended. Use a proper insulator. Here I am putting small amounts of epoxy in the edges of the sandpapers so that it will be reinforced and we may avoid direct contact to the wires and the steel frame if there's a tear there. This is what I do if I don't have a proper insulator. Okay, but if you have proper insulator like mylar paper, then you can just pass this step on. The next step is we create a support in the middle when we are going to rewind the wires, because some of the stator don't have this. We don't have that plastic that supports the wires around. So we must create one, and we will remove this later on when we are done with our rewind. After making two pairs of these, don't forget to put insulation in the part where the wires goes, so that will avoid scratching or removing the insulation of the copper wire. Okay, so we'll start our winding process. 115 turns, but I will make it 130 just to make sure that the number of turns is accommodated and to make sure that the coils do not heat up much quicker than it usually have. If you can put more wires in it, then I recommend you put more. If you can make it 150, then do it to make your field coil much cooler when you are running your power tools. Here I'm using a copper wire to secure the coils, but if you have a nylon or a zip string, then please use that. Okay, so we have done our rewinding process and we have secured our wires. It's time to put epoxy in our coils so that it will be firmly secured and prevent vibrations that may cause wear and tear in the insulation of the copper wires that may cause another shortage and burnout of our field coil. Okay, so just repeat the process on the other side of the coil and let the epoxy cure. Okay, so it is cured and I have removed the extra wires that secure in the coil and this is ready to be put back. Here I am cleaning and polishing the commutator to have a good contact point to the carbon brush. This will reduce the sparks and will increase the efficiency of current flow in the armature. I have already sanded down the carbon brush here and cleaned the carbon brush holder to make sure that it will have a good contact point in the commutator. Don't forget to try and spin the blades first before plugging in your power tool and the outlet. Test it up and see what will happen. Oh, unfortunately, we have sparks in our commutator and carbon brush connection. And I have found out that the blades are spinning in the wrong direction, as you can see here. So this spin won't cut very good on wood. So what shall we do? Well, we open up the case again, the power tool, and then we reverse the connection of the carbon brush holder and the failed coil. After reversing it, this is what it does now, guys. We have less sparks and it is spinning in the right direction. Thank you for watching, and please like and subscribe for more videos to come. Thank you.